All right, lesson 3 talks about 2 more ways to solve quadratic equations. So we have talked about factoring quadratic equations, and we've talked about taking square roots. So these 2 methods are completing the square and working with the quadratic formula. So completing the square is the first one. What we do when we complete the square is we work to create one of those perfect square trinomials that we talked about when we talked about factoring. The a plus b squared is a squared plus 2ab plus b squared, and also the a minus b squared. So the steps to do this are we move all the constants to the right-hand side of the equation. We're going to find the constant that completes the square, quote unquote, and this is always going to be my b term divided by 2 squared. We're going to add that value to both sides of the equation to balance it, factor the side with the variables into that perfect square trinomial form, and then we're going to solve the resulting equation by taking square roots. So my first example, I have x squared plus 12x minus 26 equals 2. I'm going to start by adding 26 to both sides, and that gets me x squared plus 12x equals 28. My b term here is 12, so I want to find this value, b divided by 2 squared, so 12 over 2 quantity squared. 12 over 2 is 6, 6 squared is 36. So what I'm going to do is I'm going to add 36 to both sides of my equation to balance it out. So x squared plus 12x plus 36 equals 28 plus 36. Again, all that I did, I added this, both sides of my equation. And now, on the left-hand side, we see that that is a perfect square trinomial, so I can factor this into x plus 6 quantity squared, which equals 28 plus 36 is 64. So now what I'm going to do is I'm going to solve this equation taking square roots. So I'm going to take the square root of both sides. So that leaves me x plus 6 is equal to plus or minus 8. And I'm going to subtract 6, so x equals negative 6 plus or minus 8. And I can do that math pretty easy. Negative 6 minus 8 is negative 14. Negative 6 plus 8 is positive 2. So that would be those 2 solutions to that quadratic equation. If I go to b, exact same kind of thing. I want to get all those constants on one side. So I'm going to have b squared plus 6b equals 46 when I add 50 to both sides. I want to find that value that creates the perfect square trinomial that completes the square. So my b value is 6, so I'm going to do 6 over 2 squared, which is 9. 3 squared is 9. So I'm going to add 9 to both sides. B squared plus 6b plus 9 equals 46 plus 9. And the left-hand side factors into b plus 3 squared equals 55 when I add those 2 together. And then again, I'm going to solve this by taking square roots. So when I take the square root of both sides, that gets me b plus 3 equals plus or minus the square root of 55. And then to isolate that b, I need to subtract 3. So b is going to be negative 3 plus or minus the square root of 55. And there it is. When you don't have whole integers, when you have radicals that can't be simplified, you can leave it in simplest radical form. That's fine. So these 2 equations were pretty easy because my b value is even. In C, I have that my b value is odd. So that's going to create a little extra work, just a little more reminders with fractions. So I already have all my constants on one side. So I'm going to do negative 19 over 2 quantity squared. Okay, remember, this is really just negative 19 over 2 times negative 19 over 2. Negative 19 times negative 19 is positive 361 over 4. So that's the value that I'm going to be adding to both sides. X squared minus 19x plus 361 over 4 equals 55 plus 361 over 4. Okay. Now, I imagine you're probably asking, how am I going to be able to factor that thing? I don't know if you've really noticed, but my b over 2 value is always what this constant is, creating that perfect square trinomial. So this just factors into x minus 19 over 2 quantity squared. That's always going to happen when you do that, all right? Now I want to think I need a common denominator between 55 and 361 over 4. So to write that, 55 times 4 is 220. So 220 over 4 is equivalent to that. So I can go ahead and I can write that as one fraction if I want to. So I have x minus 19 over 2 quantity squared equals 581 divided by 4. And then we solve just by taking square roots. So square root of both sides. X minus 19 over 2 is going to equal the square root of 581 over 4. And remember, right here, we talked about you can split a radical when you have a quotient. So remember that this is really equal to the square root of 581 over the square root of 4. And we know that the square root of 4 is 2. So I have x minus 19 over 2 equals the square root of 581 over 2. Plus or minus on both of those, missed that. And then last step to isolate my x, I'm going to add 19 halves to both. So my final solutions are x equals 19 plus or minus the square root of 581 divided by 2. And I, again, combine those fractions in one step. And those are my two solutions to that quadratic by completing the square. All right, D, pretty similar to A and B, again, because my B value is even. So when I move that 74 over, B squared plus 14B equals negative 84. I'm going to find that value, 14 divided by 2 quantity squared, which is 7 squared, which is 49. So I'm going to add 49 to both sides. B squared plus 14B plus 49 equals negative 84 plus 49. Factoring that left-hand side of my equation gets me B plus 7 squared equals negative 84 plus 49 is negative 35. So I'm going to take square root of both sides of my equation. B plus 7 equals plus or minus the square root of negative 35. And I know that I can pull out an I because now I'm in the complex number system since I'm taking the square root of a negative number. So this is going to be B plus 7 equals plus or minus I radical 35. And then last step, I'm just going to subtract 7. So my two solutions, my two complex solutions, negative 7 plus or minus I radical 35. So that's completing the square when the A value is equal to 1. So we also can complete the square when the A value is not equal to 1. It just takes a little bit of extra thinking and a little bit of extra work. So the steps themselves don't change. So we want to get all the constants to one side, all the terms with a variable on one side. So for A, if I subtract 2m squared from both sides, that is going to leave me with 10m squared minus 20m equals 48. So now, again, I see my A value is 10 and my B value is 20. So I can factor 10 out of both of those. That's the greatest common factor that I can pull out. So I want to pull out the greatest whole number, not variable, just the numerical value that I can. So that leaves me 10m squared minus 2m equals 48. Now what I'm trying to do is I'm going to work now with this m squared minus 2m as my quote-unquote completing the square. I'm going to figure out, I'm going to treat that negative 2 as my b value. So I'm going to do negative 2 over 2 squared, and that is negative 1 squared, which is just 1. So I'm going to keep this as that 10m squared minus 2m plus 1. Now, in your head, you're probably thinking, I need to add 1 to both sides. But in reality, I'm not actually adding 1 to both sides because remember, I factored this 10 out. So I'm really adding 1 times 10, which is 10 to both sides. So I'm going to add 10 to the other side. And now I'm going to, again, factor this perfect square trinomial, which is 10 times n minus 1 quantity squared, which is equal to 58. I'm going to divide by 10 to isolate my squared term. So that gets me m minus 1 squared equals 58 over 10, which can simplify to 29 over 5. I'm going to do that in the next step. So I'm going to go ahead. I'm going to take the square root of both. So that leaves me m minus 1 equals plus or minus the square root of 29 divided by 5. And then to just isolate that 1, I'm going to add 1 to both sides. So my two solutions are 1 plus or minus the square root of 29 over 5. So for now, this solution in this form is acceptable. It's not in full simplified radical form, but we are going to talk about that a little bit later. So for now, this is an acceptable solution. B, we're not going to worry about right now. We're going to come back to that. So let's talk about C. So again, I'm trying to isolate those two terms with my variables. So I'm going to subtract 55 from both sides. So it gets me 3m squared plus 12m equals negative 57. And I can factor a 3 out of both values on the left. So when I pull out a 3, it leaves me m squared plus 4m equals negative 57. So then I again want to find that b over 2 square value. So 4 divided by 2 squared. 2 squared is 4. So 3 times m squared plus 4m plus 4 equals 57 plus 4. Nope. Remember, again, I'm really doing 3 times 4, so I have to add 12 to both sides, and that 57 should be negative 2. Okay? So when I factor that perfect square trinomial, that leaves me 3 times m plus 2, quantity squared, equals negative 45 when I do that math. So let's now go ahead. Let's isolate that squared expression again. So if I divide by 3, I have m plus 2, quantity squared, equals negative 45 divided by 3. Negative 45 divided by 3 is 15. Again, I'm going to show that in the next step. Square root again, both sides. So I have m plus 2 equals plus or minus the square root of negative 15. And we know we can pull, again, that negative out because we're now in the complex number system. So I have m plus 2 equals plus or minus I radical 15. And then when I isolate that m, my two solutions are negative 2 plus or minus I radical 15. So that's how you complete the square when your a value is not 1. It's just by factoring something out when you can, and then taking the square root just like we did when a was 1. Okay, now we can convert from standard form to vertex form. We had to learn how to complete the square to be able to do that. So I am going to show you a little bit easier one before we do the one that's in the notes. So the first one that we're going to do is going to be on the left-hand side. I'm going to do f of x equals x squared plus 8x minus 15. So this is in standard form, again, because this is my ax squared plus bx plus c. Okay, and I am now trying to convert to my vertex form, which is that a times x minus h quantity squared plus k. Okay, so what you do to do this is complete the square. So you're going to group together the first two terms, again, the x term, so x squared plus 8x, and then you're going to leave that on the outside, the constant term. And you're going to complete the square with those two terms. So I have x squared plus 8x. And so when I do this, again, I'm finding these two values that are going to be multiplying, or when I b divided by 2 squared. So my b is 8. So I'm going to do 8 divided by 2 quantity squared. 4 squared is 16. So I'm going to have this f of x equals x squared plus 8x plus 16. Now, since I added this 16, I really need to balance the equation and it's not even, again, an equation. I need to really just balance that one side of the expression because I can't just add 16 and just say that it's equivalent to what it already was. So to balance that out, what happens is I'm going to subtract 16 from my constant because 16 minus 16 is 0. But I'm really, again, just changing the form. So this now leaves me f of x squared plus 8x plus 16 is x plus 4, quantity squared, and negative 15 minus 16 is negative 31. That is that function in vertex form. So I know it can be a little bit confusing, but just remember, you have to keep that side of the function completely balanced. So if you add something, you got to subtract it. So that way, again, you're just following the rules of algebra and keeping the rules of equality in place. Okay, let's go ahead now. Let's do the one that you're seeing in your notes. So f of x equals negative 3x squared minus 6x minus 9. So I am going to pull out that negative 3 because I can factor it out. So negative 3 times x squared plus 2x minus 9. And if I do my b over 2 squared, 2 divided by 2 squared is 1. So f of x is going to be negative 3 times x squared plus 2x plus 1. Minus 9, but again, I need to keep this balanced, so I'm really doing 1 times negative 3. So I'm subtracting 3, because negative 3 times 1 is negative 3. So to balance that, I need to add 3 to this constant value. Okay? So I can then go ahead and factor out, or not factor, out factor. So that's going to be negative 3 times x plus 1, quantity squared. And then negative 9 plus 3 is negative 6. That is that same function written in vertex form. All right, quadratic formula. It can be used to find solutions to any quadratic equation. So the only thing that you need to do with the quadratic formula is make sure that it's in this standard form. Ax squared plus bx plus c is equal to 0. And you just work with this formula. Opposite b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So step 1, again, always make sure that you get your equation in standard form equal to 0. So I'm going to add x to both sides. I'm going to subtract 104. So 4x squared plus x minus 104 is going to equal 0. So I then identify my a, my b, my c. My a is 4, my b is 1, my c is negative 104. So now I'm just going to go ahead and substitute everything into my formula. So I'm going to do opposite negative 1 plus or minus the square root of b squared, so 1 squared, minus the quantity of 4 times a, which is 4, times c, which is negative 104. All divided by 2 times a, 2 times 4. So now we literally just do the math. So negative 1 plus or minus the square root of 1 minus 4 times negative 104 is 4 times 4 times negative 104, negative 1,664. All divided by 2 times 4, which is 8. And minus becomes positive, as we know. So this is going to be negative 1 plus or minus the square root of 1,665, all divided by 8. Those are my 2 solutions to that quadratic equation. And again, if you look at it in standard form, it would be pretty tough to factor that. You could complete the square. It would be a little bit more work. So the quadratic formula is a good idea to solve this equation. If I go ahead to b, put it in standard form, so I'm going to add 11x to both sides. So that gives me x squared plus 11x minus 6 equals 0. My a is positive 1, my b is 11, my c is negative 6. So when I plug this into my formula, x equals negative 11 plus or minus the square root of b squared, 11 squared, minus 4 times a, 1, times c, negative 6, all divided by 2 times a, 2 times 1. And then we do the math. Negative 11 plus or minus the square root of 11 squared is 121, minus 4 times 1 times negative 6 is negative 24, all divided by 2 times 1, 2. So this leaves me negative 11 plus or minus the square root. 121 minus negative 24, it's like adding 24, so 145, all divided by 2. And those are my 2 solutions to that quadratic equation.